Welcome to another edition of Math for Noise. In this edition, we are looking at this problem. Suppose we are given a differentiable function g, which is defined in the open interval minus pi by 2 to pi by 2, and this function g satisfies these three properties. The first property is that g of xy is equal to gx plus gy divided by 1 minus gx gy whenever x, y, and x plus y all belong to this open interval minus pi by 2 to pi by 2. Limit h goes to 0, gh is equal to 0. And finally, limit h goes to 0, gh by h is equal to 1. What is this function gx? So we begin by finding the value of g0. Let us first assume that g of 0 is not equal to 0. Let x equal to y equal to 0 in this equation. That gives us g of 0 is equal to twice g0 divided by 1 minus g square 0. Since we have assumed that g0 is not equal to 0, so we can cancel g0 on both sides to get 1 is equal to 2 by 1 minus g square 0, and this gives us 1 minus g square 0 is equal to 2, or g square 0 is equal to minus 1, which is not possible because g is a real valued differentiable function, and therefore g square 0 has to be positive. So we have arrived at a contradiction to the assumption that g0 not equal to 0. So thus we can conclude that g0 is equal to 0. Now that we have shown that g0 has to be 0, let us try to see what is the derivative of gx. Now, g of x plus h is equal to, by the given relation, gx plus gh divided by 1 minus gx into gh. And remember that g prime x is limit as h goes to 0, g of x plus h minus gx by h, and that by this formula gives us limit h goes to 0, gx plus gh divided by 1 minus gx into gh minus gx, and this whole thing is divided by h. Simplifying this, we get limit h goes to 0, 1 by h, gx plus gh minus gx plus g square x gh whole divided by 1 minus. Now we see that this gx cancels and we can take gh common, and since limit h goes to 0, gh by h is equal to 1, and limit h goes to 0, gh is equal to 0, the facts mentioned in C and B, what we get is, so we have arrived at this simple differential equation, and if we integrate both sides, we have g prime x by 1 plus g square x dx is equal to integral dx, and if we put gx is equal to u, we have g prime x dx is equal to du, and therefore we have this to be integral du by 1 plus u square, and the right hand side is x plus. Now integral of du divided by 1 plus u square is tan inverse u. So from this we get that tan inverse u is equal to some x plus, and that would mean that tan inverse of gx is equal to x plus c, or gx is equal to tan of x plus c. That's an important relation that we have got, that gx is equal to tan of x plus c. Now we take limit as x goes to 0 on both sides. So by property B, we get 0 on the left hand side, and which gives us c is equal to 0. Therefore, we have proved that gx has to be tan of x. This solves the problem. Thank you.